Welcome to the status update of Work Package 2 related to scenarios, use cases, and KPIs. This is Maurizio Crozzoli. I work in Telecom Italia within the Wireless Access Innovation Group, and I'm the Work Package 2 leader. During this presentation, I will give you an outline of the objectives and the work organization of Work Package 2. I will describe you some achievements, the main achievements we got in Work Package 2. We'll give you a description of some details of the work performed in the tasks of Work Package 2. And in the end, I will give you an outlook on the second period of our activity, which is expected in the second half of this year. About Work Package 2 objectives, it's worth distinguishing between general objectives and specific objectives. The first general objective is to investigate high relevance beyond 5G scenarios and use cases where this technology can be successfully exploited. Suitable KPIs will be selected and new ones will be defined if necessary in the context of this analysis. The second general objective is to perform a closed-loop analysis jointly with Work Packages 4, 5, and 6 in order to find the most suitable network architecture and deployment strategy in different application areas. The third general objective is to investigate the applicability of both sub-6 GHz and mmWave solutions to the selected scenario and the corresponding impact on spectrum and DMF emission regulations. About the objectives which are specific to each task, we can list the following ones. The objective specific to task 2.1 is to define reference scenarios and identify benefits of RISE wireless systems. About the word RISE, please consider that it refers to RISE-enabled, enhanced, or empowered solutions depending on the scenario and the use case which is considered, case by case. Objective specific to task 2 is to define target KPIs and RISE wireless systems, while objective specific to task 2.3 is to establish RISE network architectures and deployment strategies. In line with the specific objectives described in the previous slide, Work Package 2 is organized in 3 different tasks. You can see them depicted here in this slide, and you can also see the milestones and the deliverables associated to each task distributed across the 36-month duration of the RISE-6G project. This slide summarizes the deliverables to be released by Work Package 2 across the whole duration of the project. 5 deliverables have already been released, which are deliverables 2.1, 2.2, 2.3, 2.4, and 2.5. It's worth mentioning among them deliverable 2.3, which contains the final results of reference system scenarios and use cases analysis performed within task 2.1. It's also worth mentioning deliverable 2.4, which contains the final results on metrics, KPIs for RISE wireless systems analysis performed within task 2.2. Deliverable 2.5 has been released as well, and it contains the first results of the RISE network architecture and deployment strategies analysis performed within task 2.3. The very last deliverable, which is deliverable 2.6, related to RISE network architecture and deployment strategies analysis, with all the final results performed in Work Package 2 task 2.3, will be finalized by the end of the project, which is month 36, due on the end of this year. The activities performed within Work Package 2 are the result of the interaction with other work packages of RISE-6G. Specifically, Work Package 3 provided support in terms of description of RISE implementations and capabilities, for instance, operating frequencies and so on. While Work Package 4, 5, and 6 provided support for use cases and scenarios analysis, each one with reference to its specific area of investigation. So Work Package 4 supported us on connectivity and reliability. Work Package 5 supported on localization and sensing, and Work Package 6 supported Work Package 2 on sustainability and security. On the other side, Work Package 7 received support from Work Package 2 for tailoring use cases to be demonstrated in either real or emulated environments. The main achievements of Work Package 2 are summarized in the current slide. First, we have the scenarios and use cases analysis, which allowed us to identify connectivity and reliability RISE scenarios. Then we have localization and sensing RISE scenarios. We identified 11 of them. Then we have sustainability and security RISE scenarios. In the end, we have RISE use cases applied to a factory plant, 12 cases, and to a railway station, have 7 cases. Then we have achievements in terms of metrics and KPIs selected for RISE wireless systems analysis. We identified traditional and beyond state-of-the-art performance metrics and KPIs. Among them, it's worth mentioning the EMF exposure utility. Then we also introduced new concepts, which are the area of influence and the band of influence. In the end, we worked on the RISE-6G network architecture proposal and the deployment strategies analysis. We introduced the following logical network nodes: the RISE itself, the RISE actuator, the RISE controller, and the RISE orchestrator. From the technical requirements defined by the work packages 4, 5, and 6, we tried to come to a proposal in terms of RISE-6G non-standalone network architecture. And we initiated a discussion on deployment strategies starting from a technical perspective. Last but not least, it's worth mentioning that Work Package 2 contributed to 13 scientific publications, either alone or jointly with other work packages. About scenarios and use cases, we investigated solutions able to implement the environment as a service concept. With reference to connectivity and reliability RISE scenarios, we tackled the technical challenges in RISE-enabled reference scenarios. Then we investigated different situations where connectivity and reliability can be either enabled or boosted, enhanced in different situations, specifically when we use a single RISE or with individually controlled multiple RISE, or when multiple RISE are used, or with a single multi-tenant RISE solution. Also, mobile edge computing as a key enabler in RISE-empowered scenarios were investigated. About localization and sensing RISE scenarios, we investigated different situations where RISE can be used in reflective mode, or in receive mode, or in transmit mode, or in hybrid mode. And about sustainability and security RISE scenarios, boosted EMF, EEE, SSE situations were investigated in case of single or multiple base stations. Then real-life use cases were investigated in the case of factory plant and railway station scenarios. All the details of our analysis can be found in deliverable 2.3. In order to assess the performance of a RISE wireless system for different scenarios, we identified the metrics and KPIs shown in the slide. We have some traditional KPIs, but we also introduced beyond the state-of-the-art KPIs, specifically the inter-self EMF exposure utility and the secrecy spectral efficiency shown in the slide. Then we define the new concepts. The first one is the area of influence, defined as the area of significant improvement of wireless connectivity enabled by RISE, and the band of influence, which is the frequency bandwidth in which any wave hitting the RISE gets reflected. In order to make a proposal in terms of network architecture for RISE wireless system, we started from the requirements placed by the work packages 4, 5, and 6. But we also started from the proposals we received from the very same work packages in terms of data control flow and signaling. Current network architecture proposal prepared by Task 2.3 is shown here in the slide. In it, we introduced 4 logical network nodes. There is device, there is actuator, there is controller, and there is orchestrator, each of them with different time granularity constraints. 3 items that came out of the discussion we had in Task 2.3 on deployment strategies, which is a problem tightly coupled with the RISE application scenario, are the following ones. First, active beamforming via an antenna array at the transmitter side and passive beamforming in the channel via RISE can complement each other and provide even larger gains when they are jointly optimized. Second, RISE can be integrated in the wireless networks in an innovative way, for instance by mounting them on board moving objects such as UAVs or even cars and public transportation. Third, in the context of MAC-enabled networks, a strong performance boost can be achieved by empowering MAC with RISE, with the aim of increasing uplink and downlink capacities, and to counteract channel blocking effects in the case of directive millimeter wave communications. Before completing my presentation, let me give you an outlook on the second period we are facing. Work Package 2 activities will concentrate on RISE network architectures and deployment strategies analysis, and the final results will be summarized in deliverable 2.6 due on month 36, which is by the end of this year. In that document, we will account for the refined architectures and deployment strategies, as well as for lessons learned from the field trials performed in Work Package 7. In that document, we will have to be able to face the challenge of defining a common baseline that aligns all basic functionalities of different types of RISE, as well as to move on in the discussion related to deployment strategies. In the end, we will have to let the proposed RISE-6G network architecture evolve towards potential extensions within international standardization body in relation also to 6G architectural work ongoing. Thank you for your attention on Work Package 2 activities. If interested, you can find more details in the website shown on the slide.